Okay, so in this video I'm going to have a look at the 2020 Higher Level Leaving Cert Maths paper 2, question 1. So in part A we have the coordinates of 3 points, 2 minus 6, 6 minus 2 and minus 4, 3. Find the perpendicular distance from A to BC. Okay, so what we're going to use here is the formula for the distance between a point and a line. Well, we've got to find the perpendicular distance from A, so that's our point, and the line is going to be BC. Now, what we've got to do in order to use this formula is to find the equation of the line BC. So that's the first thing we want to do. So let's look at finding the equation of the line BC. So what we need to use is this formula here. And in order to use that, we need a slope and we need a point. So we'll have 2 points. So really all we need is the slope m. So let's do that. So this the equation for slope is going to be this one here. And remember our 2 points are B and C. So B is 6 minus 12 and C is minus 4, 3. So we'll just identify these as x1, y1, x2, y2, and we'll stick them into this formula here. So we have 3 minus minus 12, so that's going to be 3 plus 12. That's going to be over x2 minus x1, so that's going to be minus 4 minus 6. So that's going to be 3 plus 12, 15, and on the bottom then we've minus 4 minus 6, which is minus 10. So that'll simplify to minus 3 over 2. So we have our slope. Let's just work out our equation then. So we've got y minus y1. So y1 is minus 12. So that's going to become plus 12 is equal to m, which is minus 3 over 2. And that's going to be multiplied by x minus x1. So x1 is 6. Okay, so let's work this out. So the first thing I'm going to do is just multiply across by 2. So we get 2y plus 24. Then I'm going to multiply out the bracket. Remember, we've got this minus 3 left on the right hand side. So we end up with minus 3x plus 18. Let's just bring everything over to one side. So we have 3x plus 2y, and then we plus 24 minus 18. So that's going to give us plus 6. That's equal to 0. So the point A is 2 minus 6, and we've got to find the distance from A to BC. So we're going to use this particular formula here. The distance from a point to a line is the modulus of A, x1 plus b, y1 plus c, all over the square root of a squared plus b squared. So we put all that information in here. We've got the modulus of this thing here is the equation of our line, where we substitute in x1, y1 here. So the equation of our line is going to be 3. Then we've got to put in x1, which is 2, plus b. So this is our b here, plus 2. Now put in our y1, so that's going to be minus 6 in here, and then we've got our plus c here, so that's plus 6. Put all of that over the square root of a squared plus b squared. But remember, this is our a, this is our b, so this is our a here, this is our b here. So let's put those in. So our a is 3, we're going to square it. Our b is 2, plus 2, we're going to square it. And now we just got to work this out. Okay. So let's see, we have the modulus of 2, 3, 6 minus 12 plus 6. That's going to be all over the square root of 3 3s 9 and 4, that's 13. Okay, so on the top we end up with 6 plus 6, which is 12. 12 minus 12 is 0, and the modulus of 0 is 0. So we end up with the square root of 13 on the bottom and 0 on the top. So that's just 0. So the distance between our point A, here and this line here BC is 0. In other words, this point here must be on this line here. Okay, so that I think was the second part of this question. It said, based on your answer, what can you conclude about the relationship between the points A, B, and C? Well, we know that B and C are on this line here, because we used those 2 points to find the equation of that line. And now we've discovered that A is 0 distance from this line, so A must be on this line as well. Therefore, what we can say about A, B, and C is that they are collinear. They're all on the one line. So what we can say here is that therefore the points A, B, and C are collinear. So the points A, B, and C are collinear, so they are on the line BC. Okay, so that's it for part A. Let's have a look down here at part B. So we have a diagram here and it shows 2 lines A and B. So this is A here and this is B. The equation of A is x minus 2y plus 1 equal to 0. The acute angle between A and B is theta. And the line B makes an angle of 60 degrees with the positive sense of the x-axis as shown in the diagram. So we have 60 degrees down here. Find the value of theta, so that we want to find the angle between these 2 lines here. Now there is a formula that we can use that involves this angle here and the slopes of these 2 lines. We can find the slope of this line here easily enough, and the slope of this line here is going to be given by the tan of 60 degrees. Rise over run or opposite over adjacent, whatever way you want to look at it. So let's start this then. So we will first find the slope of A, the line A. So the slope of the line A is minus A over B. So that's just going to be minus 1 over minus 2, which is equal to 1/2. So the slope of this line here, A, is 1/2. So now let's work on the other line then, the line B. So the slope of B then is going to be given by the tan of 60 degrees. And we know that the tan of 60 degrees is root 3, square root of 3. So we have our 2 slopes now, so all we got to do is use the formula for finding the angle between 2 lines using the slopes. So the formula is the tan of theta is equal to m1 minus m2, so we subtract the 2 slopes, plus divided by 1 plus m1 times m2. Now there would normally be a plus or a minus here, but we're only looking at an acute angle here, so we're just going to look at the positive solution here. So m1, let's say, is root 3, we'll use root 3 as the first one, minus 1/2, and then divided by 1 plus root 3 times 1/2. This is what we've got to work out. That'll give us the tan of theta. Okay, so once you do that, you get, you stick all that into your calculator, you get minus 8 plus 5 root 3. So theta then, this is the tan of theta, remember? So we want to find theta, so that's just going to be the tan inverse of all of this. And when you work that out, you get 33.435 degrees. Now let's just be sure we've answered what they've asked us to answer. Find the value of theta in degrees correct to 3 decimal places. So that's it. We found that theta is 33.435 degrees. Okay, that's it for this question.